Hey guys, welcome back. Today we're going to talk about exponential decay. The previous function we were talking about exponential growth, and with all of those functions the graphs looked kind of like that. Maybe they might have been moved down, maybe they may have been reflected, but they had that same basic shape. Today we're going to talk about decay functions. Growth functions get big over time, and as you might guess, decay functions get smaller over time. So kind of your generic exponential decay function would look something like so. Just as with growth functions, decay functions have many different parent functions. So the first one we're going to talk about is 1/2 raised to the power of x. So what I want you to do is pull up your graphing device, whether you're using your calculator or Desmos, or maybe the TI calculator that you downloaded to your laptop. Graph that bad boy and see if you can figure out what the two reference points are. So that's what my calculator spit out when I typed that function in. Our reference points are going to be the 2 points that I have plotted in purple. So one of them is going to be 0, 1. That should be familiar to you from the previous video. And the other reference point will be the point 1, comma, and in this case, 1/2 is the y coordinate. And just like with growth functions, this value right here winds up being the y value of this reference point. What do you think the domain and range of this function are, and does this function have any asymptotes? Well, indeed the domain is all real numbers, so -infinity to infinity, and the range is, again, remember range, we go bottom to top, so that would be from 0 to infinity, and it has a horizontal asymptote at y equals 0, just like our growth function did. Like we did in the previous video, the next function we're going to talk about is similar to what it was in the growth function. Instead of 10 to the x, we have 1/10, or 1/10 to the x value. So graph that and see if you can figure out what the reference points ought to be. So there I have it graphed, and the reference points, again, I have plotted in purple, and those reference points are going to be 0, 1, and the other one will be 1, 1/10. So whatever this number is right there will be the y coordinate of the reference point when x is equal to 1. Now that's for the parent functions, and as you might guess, we're about to start transforming those functions. So for 1/b to the x, the reference points would be 0, 1, and 1, 1/b. Now we can't really graph that because we don't know what the value of b is. On the next slide, I'm going to show you kind of the generic function, and we'll also show you the equations for getting your new reference points. So that is the generic function. 1/b tells us what family of functions we're talking about. Maybe it's 1/2 or 1/5. And then we have our old friends a, h, and k. Remember, a has to do with vertical stretching and compressing. H has to do with translating the function left and right, and k translates the function up and down. And here are the equations for how the reference points move about. So take a moment and write down those equations for moving the reference points. 0, 1 becomes h, a plus k, and 1 comma 1 over b becomes 1 plus h comma a times 1 over b plus k. So you're going to want to write those down and keep those handy. And then we're going to use those. So pause the video and write those if you need to. And we're going to use those to help us graph something like this. So as we've done with many functions in the past, we want to figure out what is a h and k. Pause the video, write those values down. So our a value is 3, h is 2, k is -2. Our parent function, the function that we have transformed, was 1/2 to the x, so that would have been our first decay function that we looked at earlier in this video. And now what is going on here? Well, what does h do? When h is 2, that translates the function 2 units to the right. When k is -2, that translates the function 2 units down, so that's going to change our horizontal asymptote and change our range. And then when a is 3, that gives us that vertical stretch. So see if you can find the reference points using those formulas that you just wrote down. Alright, so in red I have rewritten the formulas from the previous slide. Here we see h, which was 2, so our x-coordinate of this new reference point is 2, and then we have our a plus k, so that is 3 plus our -2, 3 plus -2 is 1. So that's the one that's the least amount of work. This one over here requires a little more effort, so the 1 becomes 1 plus h, so 1 plus 2 is 3, and then here we have a times 1 over b plus k. Well, a was 3, 1 over b, that was our parent function, 1/2. 3 times 1/2 is 3/2, and 3/2 plus -2 is 3/2 minus 2, and 3/2 take away 2 is -1/2. Feel free to type all that into your calculator and help you get those values right if need be. I have plotted a rough graph there. I have the horizontal asymptote graph. The horizontal asymptote is going to be y equals k, and in this case k is -2, so I have that graphed in with my little dotted line there, and then this will be the graph of that function. What's its domain and range? So let's think about all the questions we need to know. What's the parent function? Well, the parent function is 1/2 to the x. Describe the transformations of the parent function. Well, it's been shifted to the right 2 units, down 2 units, and stretched vertically by a factor of 3. The reference points we just got through calculating, and there will always be an asymptote, and it's a horizontal asymptote, and it's always going to be y equals k, and the domain of every one of these functions is going to be all real numbers, and the range of this function would have been, we should have done that on the previous screen when we had the graph, but that would be from, let's see, -2 to infinity for the domain, or sorry, for the range, and the domain is -infinity to +infinity. So there is exponential decay and how to graph those. The assignment that you'll find, you have I think 2 or 3 exponential growth functions and 1 exponential decay function, maybe. So look forward to seeing you again, maybe on a Zoom. Be glad to help answer any questions. Hope this video was helpful. Don't forget, there's also the video that the district provided on the document, and then you can always go into my HRW and watch good old Dr. Berger and his videos. And if you synthesize all that, hopefully you're going to become a real pro at graphing exponential growth and decay functions. pre-AP class, you'll want to go ahead and watch that video that I put on the Moodle about the history of the number e, and you'll need to also be able to graph exponential functions that have e as a base. All right, until next time.